Hey guys, so this is actually supposed to be the second video that you see. So if you, I just uploaded another one, like a previous in the same email. So if if you're watching this, go watch the other one. Anyway, so this is actually really similar to Chapter 5 stuff. So you notice here they gave me just a mean and a standard deviation. There wasn't really any formulas to go. And they said what percentage should go between these 2 days. This is a pretty standard Chapter 5 problem. I'm going to convert both these guys to z-scores. Then I can just use my calculator to get the percentage in the middle. So I guess I'm really just using this guy here. So okay, I got 2 z-scores I want to figure out, right? One would be, I guess what I'm looking to do is, let me pull up my little pane here. 265 and 275. What was the mean? The mean was at 269. That's there. And I want to be between 265 and 275. And I want this area right here. So I guess what I'm going to do is I'm going to convert both these guys to z-scores and just go between it on my calculator. So I guess I just use my standard, what is it? So it's 265 minus 269 divided by, what was my standard deviation? They told me what it was. 16. So one z-score, negative 0.25. And the other one is 0.375. So to get the area in between, I'm just going to use normal CDF. Was that 24.49? $24.5. All right. So if I want to get longer, okay, how many days should the longest 20% last? Okay, so what I'm looking for here is the data. They gave me this percentage. So here, let me start over here. New one. Make me a little normal curve. So I'm not super good at this. But okay, they say they want the longest 20%. So the 20% is an area under the curve. So that's 0.2. I need to find my z-score. Okay, so the calculator that we have only reads in area to a left, right? The biggest 0.2 is over here to the right. So that means this over here is 0.8, right? 80% this way. So to get that z-score, I have to use inverse norm. So there's my z-score. And so I guess I have 0.84 equals, that was the x that I was looking for, or actually is it a p hat? Just to me, it's an x. Minus my mu, which they told me was 269, divided by 16. And I just do a little algebra. Then x is going to equal, is that 0.84 times 16 plus 269. 282.44. Okay. All right. Suppose that a certain obstetrician is planning to take care of 40 pregnant women. So according to the central limit theorem, for this one, it's just like this, right? But now, instead of having sample proportions, we have sample means. So we would have an x, or I'm sorry, y bar as it is, minus a mu of y bar divided by, okay, I'm going to use the same notation. Well, you know what? I'm going to use sigma because I don't think it'll work right. Okay, and central limit theorem says that mu of y bar equals mu, and sigma y bar equals sigma over square root of n. Okay, so if we're looking here, everything is the only thing that we actually need in addition. Well, I guess if I put it all together then. Right. A lot like the original formula here, just, mu is still mu and sigma is sigma over root n. So in our case, what we have is just n equals 40, but same mu, same sigma, right? So I don't know, first I want to know the mean. Well, the mean is the same mean, right? And the standard deviation is just this guy right here. Whatever the standard deviation was, 16 over the square root of 40. And that's it. And 2.53. And there we go. Oh, so then we want to get the probability that's more than the 270. So same deal, just plug everything in, just like before, use this mean, this standard deviation, and I want less than 270. So we're here real quick. First we'll turn it into a z-score. They said 270. Yes. Minus mean, which is 269. Divided by our standard deviation we just found, which is 2.53. Gave me a z-score of this guy, 0.39, and I want to get what? It's less than 270. So if I do my little curve, we'll look in over here to that side. So I want to go from something negative up to 0.53. So distribution, normal CDF, something from the left, -9, and then it was 0.53. Is that 70.19? Oops. What did I do wrong? Oh, I use, I'm sorry, where did I get 0.53? I must have made that number up. It's 0.39. Sorry about that. I probably should edit that out, but I'm not going to. So just 0.652. If I mess this one up, though, I will do it. I will edit it out, and I'll make it look like I never messed up. There we go. So anyway, I think that's all the videos I'm going to make for now. If you're having trouble with any more, let me know. Send me an email. I can probably get to them this weekend sometime. But yeah, like I said before, everything now, this homework, Chapter 17, and the quiz is both due on Monday. So have a good weekend, and let me know if you need anything. Bye-bye. Okay, hi guys, I wanted to show you, I got this question from a couple of people anyway, but it's a pretty good example to show you how to kind of go through all this using your calculator. So first I'm going to show you the long way, which is what the book's talking about, but then I'll get back and I'll show you the short way of doing it all with the calculator. So pay attention here just so you kind of know what's going on, but stick around for a minute because you can do this much, much faster. But anyway. First of all, okay, I guess we'll go through the long way first, is how to exactly get the confidence interval. So I have a formula. There you go. P hat plus or minus E. Well, this is E, your Z star, P hat, Q hat over N. No, I'm looking in here. I guess I can see right here just from this problem I'm looking at. Just kind of say, okay, they got P hat is the sample proportion, right? P is population proportion, P hat is sample proportion. And they say, of my 550, I had 22% infected. So my P hat is going to be 0.22. Guess that makes Q hat 1 minus 0.22, which is, 0.78. You know what? I should double check myself. Yeah. Okay. And I guess our N is just the sample size. There he is, 550. Okay, so the only thing we're missing is this Z star. Now this Z star is going to come from my normal distribution. It's a Z score, and it comes from the 95% confidence. So if I have 95% confidence, what's my little paint here? Here we go. I guess I think about going between here and here, where I have 0.95 in the middle, and my Z star is that guy right there. So, okay, I guess if this is all 0.95, I guess there's 5% in these guys total. So I guess there's 0.025 over there and 0.025 over there. So what I'm actually going to do is I'm going to find this one, and it's going to be a negative number. But since it's all symmetric, I'm just going to take the positive one to be my Z star. So, right, I've given the probability. I want to find my Z score, so I guess I'm just going to use inverse norm. So I find that under distribution. Inverse norm right there is number 3. 0.025. And I guess it's 1.96. Well, see, it spits out the negative number, but I want to pick the positive one. Look, I mean, you can see you're doing plus or minus E. So effectively, if you took the negative one, it makes no difference. But if I'm thinking about E as being my standard error, I'm extending one way or the other around from a central point P hat. It doesn't make any sense for it to be negative. But again, really, it doesn't really make a big difference. But by convention, we call Z star the positive value. So if they ask you about it, negative. But okay, then all you got to do is just kind of plug everything in. I guess, let me see, what's my E going to be? E is going to be the square root of, I guess, 0.22 times 0.78 divided by n, which is 550. I guess that came out crummy. Let me just kind of make it. Not that it really matters. But there we go. And what's this going to be? So square root 0.22 times 0.78 divided by 550. I guess that's 0.017. Oops. So all you got to do to get your confidence interval minus e, which is just going to be, what was it, 0.22 minus 0.017, and that's 0.203, and p hat plus e is just going to be and so there goes my answer for this part right here. Hold on. Okay, sorry, I see what I did. And instead of re-recording, I'll just show you. Plus, you know, everyone makes mistakes. Look, I just copied it down wrong, right? I did everything here, but look at my E. I left out my Z star. Where's he? I don't know, I just didn't put him in for some reason. So he's supposed to be 1.96 times that, which is, okay, let's just go back up to there, times 1.96. Haha, 0.035. So I'm sorry, so 0.22 plus 0.035 is that guy, and minus is that guy. So I'm going between 0.185 and 0.255. I guess, right, you're saying, I know that it's 22% plus or minus 3.5%. So I know it's within 3.5% of the 22%. That within 3.5%, that's what this error is. And this is something you're actually going to hear a bit, right, when you start having these election cycles come around. They always say so-and-so has 47% of the vote, plus or minus 2%. That's this plus or minus 2%. So, okay, I'll put this in. Now, this should be right. I probably should have checked this before I went to you, but here we go. So, 18.5 and 25.5. Okay. But all right. That all being said, this is what they're going through. That's how you find the E, is with this Z star. It's all based on the normal distribution. But we can actually do this much faster. We go to stat. We're going to look in tests, and everything we're going to do from here on out is going to be living in tests. We're just going to do all of this for you. So what I'm looking for, this is a 1 proportion Z interval. Z interval is always going to refer to the mean, and we're not messing with that. We're always going to have a T interval for those. So everything, see, this is for the mean. We only have one sample. I'm looking for one proportion. There it is. One proportion Z interval. Oh, exactly what we're doing, right? So they ask for an X and an N and a confidence level. I guess here they gave us a p hat, so we actually have to figure out what the X would be. So I guess all I did was I did 22%. Yeah. Times the 550. And I get 121. Oh, so they actually, that's how the calculator deals with it. If it worked out to a decimal, you have to round it. It won't read a decimal. The confidence level, just put it in there, 95%. And there you go. All right, there's your answer. So, like I say, all of this stuff, it's all well and good, but you have a button on your calculator that just goes ahead and does it for you. So I'd say go ahead and do it that way. What we're more interested in is what it all means. So wait, what this means, right, again, if you read through the book, you see the definition, so very, very careful. When I say I'm 95% confident that it's between here, it's a kind of a tricky thing, but I'm saying if I kept doing this over and over again with 550 broiler chickens, I'm going to get a bunch of different sample proportions, right? I got 22% this time. Some other time I might get 20%. I might get 19%. I'm never actually going to know the real proportion, but 95 of the intervals that I make will include the actual proportion. So if I kept doing this over and over again, the actual proportion is going to be between those two numbers. What we say is I'm 95% sure that is between 18.5 and 25.5. 5% chance I'm completely wrong, and I'm not saying that it's anywhere closer to, it's just as easily 19% as it is 25%, as it is 20%, as it is anything in this interval. So it's talking about 95% of the intervals, not of the samples or anything like that. So I go to the next question. And read the book, read the definitions very carefully here, because they do start to matter. You'll notice the actual calculations get to be, well, if you use the calculator, you're done in one step. So what it means is much, much more important than the answer. But 95% of samples of broiler chickens, well, I'm going to tell you, and 95% of the samples, the proportion infected with the bacterium will be in the interval. Okay? There's a 95% chance the true proportion is in the interval. And we are 95% confident that the interval captures the true proportions of all broiler chickens. I can tell this is talking about 95% of the samples. So that's not good. We should be talking about 95% of the intervals. I feel like this is probably the better answer right here. 95% confident the interval captures. That's kind of what we're looking for. But mainly looking for a 95% chance of the proportion, 95% of the samples. No, it's 95% of the intervals. All the words 95% confident. Then the last part, is groundwater's criticism. Claim the sample size was too small. No, that's fine. As long as you meet all the necessary conditions, you can generalize this result. Until another study produces a different interval, the results will generalize. As long as necessary assumption, yeah, that's what we're looking for right there. Okay. So like I said, use that for here. And if you kind of look through there, as you get to the next sections, you'll be doing called a hypothesis test with proportions. If you kind of look through tests here, you'll see you got everything. T-test, one proportion Z test, one proportion Z interval, two proportion Z interval. So, I mean, I'll not that I won't keep making these videos. I'll keep making these videos. But do bother just look, and it might just be super easy to put things in. So, yeah, under test, really for the rest of the stuff this semester. And the other thing is, again, I'm